A warm welcome to Module 8 of our special quadrilateral series. The quadrilateral at hand today is the one which is common in our everyday lives. From tabletops to rooftops or bridges, you will spot them everywhere in various forms. So let us explore trapeziums. After this module, you will be able to identify the special quadrilateral trapezium, analyze its properties and apply them to find the missing values. But before we dive in, let us quickly answer a few questions. Name the quadrilateral with no set of parallel sides. Is it a kite, a trapezium, a parallelogram, or a rectangle? You may pause the video to match your learning pace. Yes, the quadrilateral with no set of parallel sides is kite, the one we had discussed in our previous module. Identify the false statement about kite. Adjacent sides are equal. Angles between equal sides are equal. The longer diagonal bisects the shorter one, or the diagonals are not equal in length. Which of these is not a characteristic of kite? You may pause the video to read the options carefully. So, as discussed in Module 7, kites have adjacent sides equal. The longer diagonal does bisect the shorter one exactly like the kites we fly, and the diagonals are not equal in length. So which is the option which is not a characteristic of kite? Correct. Angles between unequal sides are equal. Observe the quadrilateral on screen. See how the non-parallel sides are clearly visible. They will intersect when extended. In contrast, the parallel sides are marked by the red arrows, maintaining a constant distance between them. Can you identify how many pairs of parallel sides this quadrilateral has? Exactly one pair, as marked by the red arrows. But do all the quadrilaterals have one set of parallel sides? In our previous module, we explored kites, which have no set of parallel sides. And in our future module, Module 9, we are going to delve into parallelograms, which have two pair of parallel sides. But what about quadrilaterals with exactly one pair of parallel sides? These special quadrilaterals are what we are going to explore today. These special quadrilaterals, which only have one set of parallel sides as marked by the arrows and the other two non-parallel sides which are quite evident from the appearance, are called trapeziums. They have exactly one set of parallel sides. Or examine the trapezium ABCD on the screen. Can you identify the pair of parallel sides? They are indicated by the arrows. So we can say AB is parallel to CD. But what about the other two sides, AD and BC? They will intersect when extended. That means our quadrilateral has only one pair of parallel sides. So we can define our trapezium as a quadrilateral with at least one pair of parallel sides. And trapeziums are also famously known as trapezoids. Let's explore the parallel sides first. AB and CD are parallel sides. But what are they called? In a trapezium, the parallel sides are called the bases. So, AB is a base and CD is also a base in the trapezium ABCD. And what are the non-parallel sides called? The non-parallel sides are called the legs. For instance, AD is a leg of trapezium ABCD, and similarly, BC is also a leg of trapezium ABCD. Understanding these components is crucial when exploring the properties or even calculating the areas and perimeters. So let us conclude whatever we have discussed thus far. Trapezium is a quadrilateral with at least one pair of parallel opposite sides, and these parallel sides are called its bases, while the non-parallel sides are called the legs. Another important point, trapeziums are also known as trapezoids. One of the most distinctive features of trapezium is that they can be found in various everyday objects. For instance, the frame of this bicycle. Can you identify the trapezium? Exactly. the surface of a table. You can identify the trapezium or even the wing of an airplane. All exhibit trapezoidal shapes. The reason is that we encounter so many trapeziums in our real life objects because of the varying side length and angles. There is no specific characteristic for any side or any angle in a trapezium. Just one pair of parallel sides and a simple quadrilateral turns into a trapezium. I am sure you can identify the trapezium in this lampshade. Now is the time for us to conclude whatever we know about the sides. So the opposite sides of a trapezium are parallel. And what about the angles? Let us explore the angles also. In this trapezium ABCD, we can clearly see AB is parallel to CD. So angle A and angle D, if we talk about these two angles first, they are forming along the leg that is AD. So observe the leg. Remember, the legs are the non-parallel sides. So while AB and CD are the bases, they are parallel. AD is the leg, AD. So angle A and angle D. Now this leg, when we are talking about angles, this leg is referred to as transversal. So when we are talking about angle A and angle D, we will focus ourselves on the transversal or the leg AD. But what is the property of these two angles? Something that you can recall from your previous class. Transversal is AD and AB is parallel to CD, making angle A and angle D co-interior angles because they are on the same side of transversal. Observe their position carefully. They are running along the leg and they are in the interior. So they are co-interior angles. And what is the property of co-interior angles? They add up to 180 degrees. So we explored one leg, that is AD. Can you identify the other leg also? Yes, the other leg is BC. That means the angles will be angle B and angle C, and BC will become a transversal. So when we are talking about angles of a trapezium, we refer to the legs and they become the most important aspect then. And these legs are then called transversal. So BC is the transversal, so angle B and angle C will be in question. So angle B and angle C are co-interiors and their sum will be 180 degrees. So what is its application and what kind of questions can be asked of you? Find the measure of angle C if AB and CD are parallel in the given trapezium. So AB and CD are parallel. So now you focus on the two angles. The angles are angle C, which is to be found, and angle B, which is given. So which transversal or leg will you choose? You will choose BC. So can you quickly find out the measure of angle C? Angle B and angle C are formed across the same leg or transversal. That means they are adjacent angles or they are co-interior angles. So what should be their sum? Their sum should be 180 degrees. That means if I have to find the measure of missing angle C, I will simply find the difference of the given angle from 180 degrees, and this measure comes out to be 60 degrees. Mention the reason also. The adjacent angles are supplementary. You can also write the co-interior angles are supplementary. One more question for your practice. Can you find the measure of angle C if AB and DC are parallel in the given trapezium? So again, angle B is given and angle C is to be found. So which transversal will we take? B and C. So BC is the transversal. So if one angle is 160 degree, the other is going to be 180 minus 160. Something like the linear pair thing. And the presentation also you know, B plus C should be 180 because they are adjacent angles. So angle C will be the difference of 180 and 160, which works out to be 20 degrees. So what can we conclude about the angles of a trapezium? Each pair of adjacent angles along the same leg, not the base but the leg. The adjacent angle pair is supplementary. So you can identify the legs. The first leg we can identify is AD. So the angles that are going to be supplementary or the angles that are going to add up to 180 degree will be angle A and angle D. Similarly, can you identify the other leg? BC. So the angles that are going to be supplementary will be angle B and angle C. So these are all the properties of trapezium. Let us explore another application of these angles. So if they give you an angle and they tell you that it is a trapezium, you simply can subtract and find the missing angle. But at times it so happens they give you the two angles on the same side of the leg and they ask you if the given quadrilateral is a trapezium or not. So how will you prove or how will you justify your answer? If we observe this trapezium KLMN, you can see that angle M and angle L, they are sitting on the same side of the leg. So their sum should be 180 degree, which it is. So can we conclude that since the adjacent angles are supplementary, then NM and KL are parallel. So we've got our one side parallel. And also by the look of it, it is clear that KN and LM are not parallel. So we have only one set of parallel sides. So KLMN is a trapezium. So now that we have verified that this trapezium KLMN is indeed a trapezium, there is a point worth mentioning over here, that the definition of a trapezium is more inclusive than you might expect. In fact, a trapezium is defined as a quadrilateral with at least one pair of parallel sides. This means that even if a quadrilateral has two pair of parallel sides, it still can be classified as a trapezium. But we will explore this nuance in more detail in the final module of this series. But for now, let us focus on understanding the basic properties of trapezium with one pair of parallel sides. So now it's your turn to check if ABCD is a trapezium. Two angles have been provided to you. Pause the video and attempt the question. So for ABCD to be a trapezium, it should have at least one side parallel. The angles are provided to us, we will add them, and the sum should come out to be 180 degree. Is it so? It's not so. That means angle A and angle D are not supplementary. So AB and CD cannot be parallel. So, and by the look of it, we know that AD and BC are not parallel. It's quite evident from the figure itself. So we can say that this quadrilateral has no set of parallel sides. That means ABCD is not a trapezium. So now we are in a position to conclude about the angles as well. So what are the properties of angles? Firstly, the adjacent angles. And which adjacent angles? The one that are running along the same leg, not the base. And what happens to these adjacent angles? They are supplementary because basically they are co-interior angles. But what about the diagonals? Nothing special about the diagonals. They can be equal, they can bisect, intersect. For angles also, for sides also, no specific characteristic. That's all that we have for trapezium. But before we close this module, one important trapezium that you will see many a times. What is the difference between this trapezium and all the trapezium that we were discussing thus far? That the legs are equal. Something like your isosceles triangle. So here also we have AD and BC equal. So such trapeziums which have the non-parallel sides or the legs equal, they are called isosceles trapeziums. These kind of questions are at times asked. If you want to explore the concept of perimeter of trapezium or the area of trapezium, you should visit the mensuration playlist and all these are uploaded there. I will see you in the next video to discover the properties of parallelogram. Until then, keep learning, keep practicing and stay curious. Stay in the video till the end to dive into the rapid fire round and show off your math skills. I am now leaving you with questions that will challenge your understanding. Put your pen to paper, music on or mute, whatever helps you focus. Take your time and let your math progress shine and reflect.